I'm very pleased to welcome you to our first webinar under the project CommBeBiz Horizon 2020 Action. My name is Sylvia Schreiber. I will be the moderator for this session. I come from the CommBeBiz project, which means communicate and bridge the bioeconomy to business. It's all about speeding up the knowledge transfer from bioeconomy research along the value chain, and it's all about to enable researchers to do this in the most efficient way. Therefore, we created, among other actions, a series of special CommBeBiz webinars where a theme-related knowledge exchange is foreseen and where we can offer training in communication and also a series of Testinars. This is a new word creation. It means webinars to test your bioeconomy research developments with experts from the industry. Our first Testinar today we dedicated to the theme of forest and forestry-based industries. After food and agriculture, forestry is the second biggest sector in the bioeconomy with an annual turnover of more than 645 billion euro per year, and with nearly 500,000 employees. It not only comprises the forest and wood, like you see on this image, it is also about paper and pulp industry. In brief, they are in packages, in cartonnage, in printing and books, and in many other innovations, which we will see today and hear soon. Because in our first part of the forest webinar, we will hear an outlook and a keynote speech from Mr. Bernard de Galembert from Brussels. He is the Director of Innovation in the Confederation of European Paper Industries, CEPI, Brussels office. In the second part, and he will have his keynotes first about the outlooks and the prospectus of this very, very interesting and highly innovative branch. In the second part of our session, we will turn to our Testinar. 4 EU-funded projects were so kind to offer some material and some knowledge, and they will be presented in flash mode, and then we will hear an evaluation from our expert, Mr. de Galembert, about their market and innovation potential and their uptake of industry. So I have also the pleasure to introduce you our technical moderator. You can't see him now, but if anything is going wrong or going miss, Edward Barnes, who is our technical moderator, will help us and bring us forward. I think this is enough for introduction, and I have the pleasure to give over to Mr. Bernard de Galembert for his speech on paper and pulp industries and the innovative outlooks. Please, Bernard, you have the word.
Thank you, Sylvia, and good morning, everyone. Thank you for attending this webinar. I'll try to portray rapidly, and I check it works. Yes, portray rapidly what we see as the future of not forest-based industries as such, but rather the pulp and paper industry, which is my area of competence, and where we see innovation and the bioeconomy as really the future of this industry. But to know where we go, it's good to know where we are today. And if we look at where we are today, we see that out of the traditional products that this industry is delivering in Europe, there are 2 grades or 2 segments that are performing rather well, if not very well, and we're thinking of packaging and tissue here. And it's true that the more you buy on Amazon, I would say, the better for the packaging segment. And it might sound a bit cynical, but an aging population is also an opportunity for the tissue segment. So as you can see on the graph, you see there are 2 segments in the paper industry that are performing rather well in Europe. But there is a sunsetting segment which is harshly competing with the digital sector, and it's the graphic and newsprint and printing sector. And you can see on the graph that this all is reducing and shrinking quite significantly over the years. So this is the current status and the current perspective into the pulp and paper industry in Europe. And if we want to keep this industry competitive in the future, there is something vital, which is the need to innovate, to keep ourselves out of the pack. We have China, India, Brazil competing with us on the bulk, and we need to come out with new products and new processes to be competing or competitive. When we speak innovation in the sector, we see basically three broad categories. We can improve the process. It's making pulp and paper that we know currently better, more resource efficiently, more energy efficiently, better productivity, etc. The second way to innovate is by making these products we know well more innovative. And there we can do smart packaging, we can do intelligent paper, we can do intelligent packaging. So it's still paper, but it's paper with new features, new functions that add new or that provide new solutions to the market. And then there is the open space of new products, and that's where we feel we are pioneers into the bioeconomy, because with wood and lignocellulosic raw materials, we can produce a much wider range of products. Some are already on the market. I'm speaking of, for example, food additives, and there is a Norwegian company who is leading on the wood-based vanillin production. So cosmetics, but also pastry, etc., contain wood as a main ingredient. If I go to the first type of innovation, process innovation, I've tried here to portray the paper making process. And this to reflect on a process we have been going through 2 years ago, which was a way to explore how to decarbonize the industry by 80% by 2050. And to do that, we have put 2 teams in competition who have been looking at the most energy intensive and most carbon emitting parts of paper making. And it's probably not that clear on the graph, but the drying part, which is at the bottom right, is the most energy consuming and the most carbon intensive part of the process. And with this concept of putting 2 teams to compete and invent disruptive ways to improve the paper making process. Sorry, and it doesn't come on the graph unfortunately, but they've invented 8 breakthrough solutions to improve the paper making process. And among them, it's about using steam instead of water, it's about using supercritical CO2 to dry paper, but also a deep eutectic solvent as a solution to dissolve wood into lignin, pure lignin and cellulose. And all these concepts that have been invented over 1 year by the 2 competing teams are now under development or in the process of being developed further through more research, more innovation, and then demo and pilots. The next innovation trend is just by improving the functions and the features of existing products. And here you can see different type of products. So chromatogeny that makes paper water-phobic with the pink drops on the right, but also smart labeling and DFIDs, printed electronics, cups that react to the temperature to show that the beverage is either too hot or not hot enough, but also packaging that informs you about the status of the product it contains in terms of expiration date or peremption date, I don't know how it's being said, or the freshness of what it does contain. That's these new functionalized products that the paper industry can deliver. And then there is the broader range of the bioeconomy and bio-based product. And here again, I've tried to show the various ranges of products that can be made out of wood. You have 3 shirts. You have the UPM car, which is a concept car, 25% lighter than traditional cars, and with new composite materials, new plywood being used in there, the car being fueled by biodiesel from wood. You have chemicals, you have cosmetics, you have turpentine, you have the plant bottle of Coca-Cola. You have a wide range of different products, including food additives that the bioeconomy could deliver out of wood. And all these could definitely not happen, and I want to point at that, without fundings, which are important. And when we will look later on at the 4 projects or research projects, they all, I think, rely on some public funding coming from either national fundings, but also international and European fundings. And we have here an example of all these opportunities, be it under the structural funds, the Smart Specializations platform, or with the money from the emissions trading scheme, NER 300, or the framework program for research, Horizon 2020, the bio-based industries public-private partnership, which grants or will grant 3.7 billion euros over 7 years for the bioeconomy. So a wide range of funding opportunities there that we must consider when looking at innovation in the pulp and paper industry. The future of the industry is still promising, and I wanted to point at that and emphasize that, because there is a feeling that the paper industry is an old, conservative, traditional industry that will be replaced indeed by the economy, the electronics, the digital, etc. We see in CEPI 5 billion euros of investments within the next 2 years. And they have been announced, so it's not a fairy tale or it's not a dream, it's a reality that will come soon. We have, as I've shown here, CEPI investing in nanocellulose, which is seen as a fantastic opportunity to improve the quality and the performance of our products, but also Metsä Group investing into a biorefinery in Finland. And as you can see, the amounts we put there are above 1 billion euro. And a pulp mill still to be built in Finland, announced by Pulp a few months ago. So the industry's outlook is in that respect quite promising, as there is several investments to come. So that's how we see the future, an innovative industry with a wide range of products ahead, but still paper and pulp at the core of it. Thank you very much.
Thank you very much, Bernard, for this very interesting outlook and tour d'horizon about paper and pulp, which is much more than we all know, I guess. And if there are any questions, our participants are invited to ask them in the written chat, with the written chat function after each of the presentations. I also have to make some technical information. All the material and all our presentations and the speeches from this webinar are recorded, so that you can download or retrieve them afterwards on 2 different sources. First, it will be downloadable from the CommBeBiz website in the button in the section Library of Resources in around 1 week's time. And the next source will be available on YouTube, and web link for that you will find on the very last slide after the 4 case studies which will be presented now. So all technical details we will find on the last slide of this presentation, how to look back, how to review, and so on. We come now to the second part of our session, which is the Testinar for EU-funded research projects along the value chain of agroforestry and agroforestry-based industries. We have selected for you, and they were so kind to answer to us the questions which is not actually known about their development stage, for instance, or what product could come out, or what will the future clients be. So they presented to us their information, their facts and data, and we assembled them and on the slides, which will be put on the screen by Edward, I think so. Yes, here we are. It is our first Testinar, which is a business readiness check of research developments in agroforestry-based industry, and we will start with SteamBio. Oh, open the slide from SteamBio. I try to scroll. Yes, here we are. So SteamBio is about valorization of agroforestry biomass. In brief, this research project has to render agroforestry waste from remote areas, from mountaineer areas, high up the north or deep south, to render them in packages which are easy to send, easy to ship to the places where they are used, to paper and pulp mills, or to the biorefineries, which are centered around industrial zones or centered around ports. And the waste in raw status is really heavyweight, and it's bulk and encumbrant, and therefore these projects try to treat this. It tried to treat these wood waste with steam to minimize and to decrease weight. So the agroforestry residues, for instance straw, wood waste or prunings, they contain really valuable stuff. It's lingnocellulotic material, which is a high value precursor material for biorefineries and for the pulp and paper industries. The issue is that the abundant forest and farmland wastes with the wealth of these biomass stuff are located throughout remote regions in the north, in Scandinavia, in the Baltic states, or in the south, in South Spain. The logistics involved in transporting these abundant wastes, biomass, is yet untapped, and it's difficult to make this logistics, and therefore the challenges are to render with a novel approach a cost-effective transport to the industrial biorefinery customers. So the SteamBio project has answered to us, will be a mobile steam treatment with increased energy density and decreased volumes. The core technology inside is superheated steam processing these agroforestry residues. The tonnage will be processed with this superheated steam up to temperatures of 300 degrees Celsius. This reduces the water content from over 40% to less than 5% and allows uncovered transport of lorry loads with the stable biomass to the industrial customers. They need for this purpose engineered devices, so to say a mobile superheated steam unit which is located in the remote area and which will process the material in situ and according to seasonal demand. So the idea is to move these mobile units, which is a lorry with a steam heating unit on, from valley to valley in the harvester time. It is a disruptive technology approach which will deliver pure and non-contaminated biomass, and the condensed steam will provide a source of volatile biochemicals and pure water, which then is suitable for irrigation on farmlands. The products will be torrefied lignocellulose packages which are derived from these sustainable agroforestry sources without pollution emissions. I move to slide 2. So the research project process in the moment is testing and scaling up. So they have 5 regions picked out across Europe where they test different wood materials. So they select 6 different sources and they demonstrate this as an industrial scale in situ during 2017, how this steaming and torrefaction can be implemented and what quality and properties from the materials will come out of these projects. The steam biotorrefaction will then offer advantages against the conventional torrefaction approach, which use flue gases at a heat exchange medium and which pollute the steam and the water, and the SteamBio approach will to offer pure material which can be recovered after the process. There were two precursor projects in FP7. It was Bioecosim and Euro pruning, and this new project, SteamBio, will capitalize on the lessons learned there. The ambition is that during the project demonstration phase, which will take place in 2017, 500 kilogram per hour should be processed in this and there will be experiences with 6 different agroforestry materials from different rural locations, and each material should processed in an amount of over 10 tons. This validation phase during the project will then enable to subsequent post-project commercial operations of both the mobile units and the fixed units, and it will give some rural areas some new job and growth opportunities. The development stage of this project is on the way to demonstrator, so they want to have, they are now on the level of a technology readiness level of 3 or 4, and then at the end of the project in year 2007 they will come up to the level of 6 or 7 with their demonstration project, with the demonstration platform. The future applications and clients of SteamBio, there will be flexible business models for rural areas, for remote areas, there will be new chemicals, and it will be for the energy industry. So it will be a rural empowerment, and there will be pre- and post-handling platforms for steam-treated agroforestry waste streams, increased in energy density and decreased in volumes. Clients will be public and private forest owners, harvesters, rural logistic companies for transport and storage, energy plants, biochemical refineries, and the paper and pulp recycling industry. So this is in a nutshell what SteamBio does, and I give over to Bernard with a question: do you think there will be an uptake from the paper and pulp industry for this material rendered by this project? It's over to you, Bernard.
So thank you. Yeah, you're putting me in front of quite a challenge, because I'm everything but an expert dealing with policy here in Brussels. But I found this project and to be honest, the 3 others very interesting. And the starting point for me to find this interesting is because my belief is that there will be a need for an increasing amount of renewable feedstocks in Europe. And this not only because I still have the conviction that our industry, the pulp and paper industry, will be competitive and performant here in Europe, but because there are other needs into the overall bioeconomy, into bioenergy, etc., which will lead to an additional need, in my opinion, for feedstocks, and in particular lignocellulosic feedstocks. So in that respect, cost-effective mobilization and transport of feedstocks is, in my opinion, crucial in the future to make sure that this part of the production cost into the bioeconomy and into the industry is kept as low as possible, and SteamBio could be indeed a solution. I have to say I was amused with the fact that the technical proposition here is to use superheated steam as a drying technique, because it's something we have explored as a drying technique for paper. So it's indeed something that works for sure, and bringing the drying technique close to the source of the raw material is an interesting option in my views. So of course it's difficult to assess fully the cost of it, and whether it would allow making really the raw material cheap for, or keep it as cheap as possible for the industries, because at the end of the day it's part of the game. It's to buy the raw material as cheap as possible. So let's see indeed when this project comes to the demo stage how the economics of this work, but in principle the idea of optimizing the raw material flows for the industry and the bioeconomy seems a convincing and promising option.
Mm-hmm. It is waste, so no new trees need to be felled or no new land need to be cultivated for this. It's coming from the so-called second generation biomass, which is in fact the residues of trees and pruning.
But honestly, I think it can be used for any kind of such raw material.
Yes.
Because at the end of the day, it could be first ends or first raw biomass that could be also processed like this if it makes it easier to transport and allows to feed not only the most remote installations but also the close by installations would be interested in, I suppose, in this process and in biomass torrefied via this process.
Yes. Again, but there was an issue about land for food and agriculture versus land for biomass and fuels. And a way out of this dilemma would be this rendering for waste material and bring it to the production sites. I think that is also an idea behind.
Yeah, the reality in Europe is that this fuel versus food or wood versus food issue is not as critical as it may be in other parts of the world. Honestly, there is plenty of raw material available and untapped sources of raw material in Europe. So there is room to increase the mobilization, and I think this approach could be a way to increase the mobilization in the domestic sources of biomass without creating further competition with food, for example, or without leading to converting land in Europe.
Mm-hmm. Very good, yes. And I think this applies especially to forestry. I think we can, thank you very much, Bernard. I think we can go over to our second case, which is also dealing with wood and wood waste, but from a quite different source. It is our project HYSER. And HYSER, you will see about, is about construction and, oh, I was one too fast. It's about construction and demolition waste. So HYSER will facilitate a better recycling of construction materials. The project goes beyond wood. It also applies for stones and metals and minerals. But here we have cast a look on the wood side. So there are tons of wood materials in construction and broken down houses, and but only a fraction of this wood and these overall materials which is in the broken construction is recycled. So this includes organic materials such as wood, paperboard as well, and paper. The cost-effective and sustainable recovery of the raw materials from this construction demolition waste is vastly underdeveloped. The gaps identified and tackled during the project lie in better auditing, in tracking and forecasting of the waste in buildings and in refurbishment, and it deals with sorting, recycling, quality assessment, and developing of new recycled construction products. So HYSER, which is an acronym for the Holistic Innovative Solutions for and Efficient Recycling and Recovery of Valuable Raw Materials from Complex Construction and Demolition Waste, has as main objective to develop and to demonstrate novel, cost-effective solutions for a higher recovery of these raw materials. So the focus is on closed loops for different waste streams and wood among them. The HYSER product at the end will be upgraded recycled products from wood, for instance, wood plastic composites. There will be new concepts of cost-effective sorting, cleaning, and commuting for the recycled wood to improve the wood quality and to upgrade them to materials like innovative wood plastic composites or gypsum plasterboards. There will be higher levels at the end of the project of this recovered demolition waste in the wood sector from 31% from 2.4 million tons to 5 million tons by 2030. The research project is in the moment to develop and to demonstrate the cost-efficient solutions. So there will be better procedures, there will be better technologies for advanced sorting and recycling, as well as an inline automated quality assessment of the purity and quality of the raw materials. These solutions will be demonstrated in demolition projects and case studies across Europe, and the quantification of the economic potential and the environmental impact of HYSA solution belong to this project. The development stage currently is proof of concept, but they want to develop demonstrators. Some of them you see below. Recycled wood can come up to new buildings, but it can also come up to layered material or really new polymers product like this plastic can you see at the bottom of this slide. Currently they are on technology readiness level of 2, but in the end, after 48 months, they will have reached level 5 or 6, which means demonstrators are out in the field for further testing. So the applications and the clients will be recycling companies and wood end product manufacturers. So the main partners in the project are SME and large companies from the wood material recycling and also wood plastic composite and plasterboard industries. HYSA makes converge the construction and demolition wood material recycling companies, which can upgrade the recycled wood to higher quality fractions than used normally, and it can serve for energy purposes, for end materials, and also offering new business opportunities. Next steps will be to talk to industries, and also you see here at the bottom some examples of future projects. These are these wood plastic composites which can be used for framing windows or for framing doors, for instance. So this is about another source of wood which might be one day also for paper and pulp. What do you think, Bernhard? What's your view on this project?
I mean, again, connecting to what I said before, increasing the amount of renewable raw material is key in Europe if we want to decarbonize the economy and move to a climate-friendly product. So in that respect, this project is also of much interest. And there is a particular momentum with the ongoing discussions on what is called here the circular economy in Brussels circles, which is indeed about the end of life of product and how can we promote reuse, recycling instead of landfilling or incineration. And so this project is perfectly fit for that policy context or that momentum. Now I have to admit and confess that my area of expertise in construction wood and demolition wood, if I can put it that way, is very low. But it's true that when I'm talking to my colleagues here in Brussels who represent that kind of industry, they also see an opportunity in reclaiming and recovering as much as possible this type of raw material, where we know that there is a high risk of contamination of the wood, a high risk of different products in there, be it paints, glue, but fungicides and other products that could possibly make it less usable or recyclable. So any project that would allow to increase the share of such recovered wood made available or back in the loop is of course interesting. Now what I could not really, and again I'm probably not the right expert. What I could not really get from the presentation of the project is what would be the technology. So the intention is extremely good. The intention and the target as it has been set for 2030 is quite a stretch. So let's see how it goes and how it will be achieved to get there. But again, I mean, the first glance at the project shows that there is a potential, because I believe that wood reclamation and reuse and recycling is critical for the moment.
Mm-hmm. Okay, thank you very much. So far from Bernard's side, yes, very interesting, this recovery, but a big challenge still to sort, to clean, and then to have purified materials, which will not be easy, but I think it's good that they tackle these challenges, because as you said, the circular economy will, well, not end. It's just started as a philosophy as a new paradigm in industry, the life cycle assessment and the circular economy. Thank you very much. I think we will move on along the value chain to our next project, which is Indox. Indox is also dealing with products, actually with fungi. And you never think what all is inside the fungi, things, miracles you don't see, because they have, which we know since long, a big power in the natural decay of lingnocellulotic biomass. You know, when wood is occupied by fungi and certain microbes, after a certain amount of time, the wood will not look like it did before. And these materials who drive this decay and this chemical process is looked at by Indox, because there are very valuable biocatalyst enzymes which act as biocatalysts and which can improve the whole chemical industry. So the Indox story is about natural options to change the production of chemicals by oxidative processes. So basically all processes of life are influenced by this reduction and oxidation. So what we know from corrosion of metals or from cellular respiration, it's redox reactions. Many industrial processes are also driven by oxidative processes, but often these processes use harsh and potentially dangerous chemicals in extreme reaction conditions, and so they produce undesirable side products. The Indox project and its forerunner was called peroxycats. They demonstrate that there are natural alternatives to these chemical materials, and they come from fungi or other microorganisms, and they are the so-called microbial oxyreductases. These enzymes offer exploitable sources and new routes for transformations in the industry, but they are limited available, and when they are available, they might not be suitable enough for industrial processes, and Indox tries to tweak these natural resources to make them more suitable for industry purposes. So the Indox products are improved biocatalysts and optimized processes. So there will come out of this project novel fungal enzymes. So the fungi involved will be engineered to this focus of the project, to use optimized oxyreductases on targeted oxidation reactors, and to establish the project's scalability, sustainability, and cost efficiency versus chemical conversions processes currently used in the industry. So they can be used for agrochemical productions, active pharmaceutical ingredients, for polymer precursors or functionalized polymers for the pulp and paper industry. I highlighted this for the discussion afterwards, or also they can be for intermediates for dyestuffs and fragrances. Also, Indox product and the project looks after a more stable manufacturing. The current industrial application which use these enzymes these natural enzymes are limited to amounts of less than 20%, mainly due to the limited compatibility of natural available biocatalysts with the rigorous processes used in industry. Indox will address these bottlenecks by enzyme engineering and process optimization using state-of-the-art technologies. Thus, a suitable oxidation and oxyfunctionalization bioprocess could come out and will be developed and demonstrated later on. The research process is to screen and to engineer. So the researchers in the project screen fungal genomes and cultures, and this has led to the identification of more than 3,000 new sequences, and from these they picked promising candidates, promising for the industry. They have improved by enzyme engineering tools and towards more catalytic activity, towards a better substrate specificity and the adaptation of bioprocess requirements. Currently, industry-driven demonstration activities are prepared for the second half of the project. So the development stage in the moment is proof of concept, but they think that there will come out some interesting applications after the project, which can be aromatic compounds for the perfume industry, for the dyeing industry, new polymers in the plastic industry, but also for pulp and paper. And it has to be demonstrated if all these new applications are technical and economical viable. So the applications and the clients, the applications will be in manufacturing industry, agrochemicals already have been mentioned, in pulp and paper, pharmaceuticals, household chemicals, textiles, also cosmetics, dyestuff and fragrance, but as well as food and drink. They are also considered to modify lingnocellulotic biomass and to lead to some fractions, which could also be very interesting for future fuels production and chemical production in biorefineries, which are based on these lignocellulose feedstocks. The clients will come from chemical industry, from pharma, food, fashion, paper industry, and the biorefineries. And the next steps are promotion. So in the project there are SME, but also a very, very prominent enzyme producer from Denmark, and the industrial managers from the industry inside the project. They will promote this in their own sector and will use this for the current client, but they will also find customers outside in new branches, and therefore short after the project, some interesting high valuable end products are expected to come to the market, and the industrial participants in the consortium will look after the spread and the market uptake. So I think it is very roundly composed, this project, but I would be interested to learn from Bernard now if he sees some interesting applications for pulp and paper as well. So over to you, Bernard.
Thank you, Sylvia. What to say else than wow to start with, because the feeling is that indeed we have still much to learn from nature, and that at the end of the day, using mushrooms to replace chemicals, if I can do that shortcut, is a very, very interesting option. And it makes me think, of course, of one of the outcomes of our own project when we were discussing the possibility to improve the energy and climate efficiency of paper making, and where we found these natural dipotectic solvent which can be found in plants, and that would allow dissolving pulp into its main components. So I think green chemistry, if I can put it that way, is still in an infancy stage, but looks very promising. And when we see these kind of propositions, it looks indeed very, very promising. Key question will, of course, and I think it's somehow visible in your slides, will be the economics of this. The concepts as such seems to work, but as always, when you develop an alternative to something that does exist, not only it must be as good, if not better, in terms of performance, but it must be economically at least as viable, if not more cost effective. And this is, of course, what the consortium will have to assess on the way of further developing this project. This is valid for any solution that we will find anyway in the bioeconomy and the bio-based industries, is that we will have to demonstrate in many respects how best we are, or in what way we are better, not only in terms of performance but in cost effectiveness than the alternative products from the fossil-based industry or from the chemical-based industries that we want to replace with these alternatives. So yes, for me, as such, an option that allows to reach a high level of purity and quality into the building blocks or intermediates or into the products that we want to achieve, and this with a natural-based process, is a very good way forward. I'm curious to see, as I said, the euro figures at the end of the day, because the economics will be critical for the success of this project.
Yeah, I think, thank you very much, Bernard. The keyword is system integration. This applies also to the next and the last project we want to present. It's the AP3LE short Apple project. And it deals with something very interesting. It's about smart paper-based products. So it is new functions for paper, and the key of the technology is to integrate electronics into paper substrate, into paper structures. So they start from a very, the Apple people told to us, they start from a very low level of innovation in the paper industry, but they want to develop the next generation of sustainable paper-based products with total new autonomous functionalities. So in short, that are papers who can interact with consumers in very many various ways. It will be innovative printed electronics in the paper, and it will be for information technology, medical safety, smart labeling in food and environment, packaging, and posters. So the Apple product, in brief, are novel paper-based products interacting with the users. They will invent, or they will have to invent, new materials in the paper sector where these electronics, the little monitors, the little chips, can be included. Fiber-based products, but also nano products, and the nano are very interesting candidates for these electronics in the paper. Also, novel polymer developments could substitute plastic coatings in printed material and offer some new electronic functionalities, like a plastic paper that reads like a newspaper but can be uploaded every morning with new content from the electronics inside. So it's easy to see they need new components, and they need a new manufacturing of this novel printing technology, which all has to be invented. And this is all about Apple. So the research project process is integrating already existing components. So the researchers here provide the development of the new materials, paper and fibers, and also new electronic components which entail the design and integrating in paper substrate. Also, they develop new printing processes. The industry and SME in the project are the technology providers for the development of the functional inks, of advanced base developments of manufacturing processes, and finally also an online product control for the SME who will apply these new technologies. Current development stage is prototyping, so the team has developed a type of environment and safety labels which can interact with consumers. Bernard initially showed some milk cartons, some milk package where some safety labels are in, and they demonstrate the freshness, the physical freshness of the product. They also tested already different types of paper and their printability, and they tested embedded electronics into printable paper products. So TRL5 is endeavored for, and the applications and clients will be manifold. So these smart labels, they can control product quality in food sectors, but also for the medicine industry. They can control air quality in cars, in houses and industrial environments, and answering thus different social needs. They also can establish new coatings for paper products by reducing plastics, and the new nanofiber materials. We also will revolutionize the paper industry with high-tech electronics really embedded in the structure. The clients will be high-end manufacturers, food and pharma industry, agro-manufacturing, environmental regulators, print and publishing, and graphic design. So the end-user-driven markets, the project Apple told, is huge, but it is not aware what sits in for them. So the current target group, for instance, can be graphic companies, but they are very small. They employ, for the majority, less than 20 persons. The transfer of experience and knowledge to them in this project will be key for market uptake. So demonstration and workshops on industry trade fairs are for them the means to spread their knowledge. And I ask Bernard now, I think it's one of the core business, paper industry. Is this the future of the paper industry? What do you think? Over to you.
It is the future of the paper industry. For long, the paper industry has been, and that's one of the findings we have made, has been producing bulk paper. It was sold in tons. So we were not selling solutions, if I can put it that way. We were selling tons, volumes, while the buyers were looking for surface, and a surface that was delivering certain performance. And when we move into this kind of products, we are indeed in areas where Europe can have the leadership, because on bulk production paper, China, Brazil, and other parts of the world will be much better off than we will ever be now. So I think it's extremely promising. I have to confess I've seen a prototype of such product. So I see much better and clearer probably what it's all about. What you've put right in the slide as well is the market uptake. That will be the critical element. And it's not only about the printing sector and whether the printing sector will be interested in this product, but it's beyond the printing sector. Will the final consumer be interested in functionalized paper? Will it bring a real added value? Will they be interested in a smart labeling that shows that, let's say, the cold chain has been fully respected or might have been broken? These are the key questions, and the interest of the consumers will be critical at some stage in the process next to the printing sector, etc. So that would be my main comment on this one. I think this is indeed something extremely important. Functional paper, I have put that, or functionalized paper, I have put that in my own presentation, and I see this definitely as part of the future of the European paper industry.
Thank you very much. So the outlooks are highly innovative, and it will be also, as you say, not only a question of good research, it will be also a question of perfect marketing and market studies and reach out to new circles and new consumers. We still have, I think, some 5 minutes, and if participants are out there who have questions, please ask them now. You can raise your hand and we can take your written questions and try to answer as good as possible. So, obviously, no questions, all needs satisfied. Then I thank Bernard very much for your contribution, for your very good introduction in the business and its future. I thank the four researchers who have contributed with their flash presentation, giving very interesting insights what is forestry-based industry. I hope we have now a bit clearer look that this is wood and tradition on the one side, forests, nature, but it is also a highly innovative sector with highly innovative prospects for Europe, and it's just to develop and to discover. Thank you very much for your patience, for your participation, and you can download, as said, from the CommBeBiz website within 1 week all material we have recorded today. Thank you very much and goodbye.
Thank you. Goodbye, Sylvia.
Bye, Bernhard.